Hi, so I'm Danny Williamson. I'm a lecturer in statistical science here in the maths department at Exeter. I've gone for a rather bold title there. It is exciting if you like statistics. So you're looking at a climate model. In fact, it's an ocean model. This is a simulation that took about a month on a UK supercomputer to run. And a climate model is kind of a function you run in a computer that has a whole bunch of knobs that control how it works. So this is cool, this is showing the Gulf Stream and everything, but actually it doesn't really look a lot like what we see in the real world. Actually what we see in the real world may exist in this model somewhere, if only we can find the right setting of all of these knobs that the climate model has. So this one has about 22 of these knobs, so you think, well, how can we find settings of these knobs that look like the climate? Might not sound too difficult, but if we think about this room is a 3-dimensional space, and I'm looking at a 22-dimensional space. Would it be difficult to look in this room for an orange without using your eyes? Probably. It's like a big game of 22-dimensional battleships. And you sort of guess, is it there? No. Is it there? No. What can you do with that? Well, the answer is you can use some cool statistics. So I'm going to a slideshow now, I guess. F5. Thank you. You can tell I also don't use Windows because I'm a statistician. Okay, so this is what some of the data from the climate model looks like. Over here we have salinity, effectively the saltiness of the water. And at each level we're looking at a different part of the ocean. So right at the top we're looking at the surface, and we've averaged the saltiness over the whole world. And you see these two red dashed lines here. They provide the data window that we're looking for. So we're trying to find lines that sit within this band. That's our orange. Can we fiddle the knobs until we get the orange? Well, you run the model on the supercomputer, it takes a very long time, and you get all of these grey lines, and you found no oranges. And using some cool statistics that we partly came up with here, and partly in the previous life in Durham, we have a method of running some experiments, getting the grey lines, doing some statistics, then we run it again, and we start to get blue lines. And then we repeat, we get the yellow ones, and now we're on the purple ones. So, we'll look at this picture now. What we've done is we've taken away the climate model and the data, so that if we had a perfect model, we'd be running all the way up 0. We'd have perfect salinity in the water. This big blue line here is what the climate scientists have been using as their ocean model for the past 10 years. It's scaled by number of standard deviations, so this is 10 standard deviations wrong out here. To put that in context, we only needed to find a 6 standard deviation event to prove the existence of the Higgs boson. So this is quite extremely wrong. You can see how, though we're perhaps not correct everywhere yet, we're converging. This is ongoing work. We've got the same for temperature. In fact, arguably, we're looking better for temperature, and we've got 12 standard deviations wrong for the traditional stuff over there. Got a nice stuff going on. So that's research that I'm involved in with climate models, but I wanted to give you a flavour of other things I'm interested in. This is my terrible XKCD cartoon. So I'm interested in the sort of foundations of the subject. What does probability mean? What do we mean when we ask questions like, what is the probability of this happening? What is the probability that the MOC will collapse, or that the world will warm by 2 degrees? What does that mean? And I am one of the very few people in the world that would contend that the probability of anything doesn't exist, and that would be a meaningless question, therefore, at the top. So I'm going to try and illustrate this on someone. You over there, what's your name? Yes? Tilly. Okay, so we're going to focus on Tilly slightly, and we're going to focus on the event that Tilly had toast for breakfast this morning. Now, probability is a measure of uncertainty. So we measure distance in meters, we measure time in seconds, we measure uncertainty with probability. So we have an event, that Tilly had toast for breakfast this morning, and this event has already happened. Tilly has some unique piece of information here. She has probability 1 if she had toast, or 0 if she didn't. Whereas everybody else in here, unless her parents are with her, everyone else in here has no idea. In particular, I might think, well, what's my probability that Tilly had toast for breakfast this morning? And I might ask questions like, well, so some people don't eat breakfast, that might be about 30%, and cereal and toast are pretty popular, so they're quite likely. English, full English on a Wednesday, that's a bit extravagant. Bacon sandwich, who's got time for that in the morning? So I think I might give it 30% toast, 30% cereal, and I've got 10% for a pasty on the way to work or something. But you might all think differently, and certainly someone who's been to Tilly's house for breakfast and has seen her eat toast or not eat toast might think something different too. So we all have different probabilities. And the interesting research question is, how do you bring all of those different opinions, those different notions of our own uncertainty together to try and answer science questions, to try and make decisions in the real world, to try and make policy? So that's another branch of interest. I have some others that I'm just going to list here. It's a very nice job where you can just dip in and out of lots of problems that you like, work on them for a bit, have students work on them for a bit, move on to something else. But the job isn't just research, it's not just teaching, talking to interesting people like you, and not just admin and organising things. There's also a lot of travel, a lot of adventure. So I'm going to show you some snapshots from my first year as a lecturer, so this year just gone. Here are all the places that work has taken me to give talks. So we have Banff, Canada, we've got Aspen in Colorado, Boulder, Savannah, Georgia, that's Cancun, Mexico in the middle, me with the coconut, that didn't have any vodka in it. Zurich, Munich, that's near Munich, mountain near Munich. All of these places, invited to give talks, met lots of different new people. It's much more than just a job. It's a whole life, and I guess I'm completely lucky to be involved in it. But you could be too. We have a massive shortage of these lecturers. Lancaster advertised for 4 last week. Bath advertised for 5 a couple of weeks before. There's no shortage of jobs, just a massive shortage of people. So please get involved. It's a kind of Navy-style advert, though I would say. Perfect, Simon.